So this is the 2016 Junior Cert Ordinary Level Paper 2, and we're looking at question number 11. Part A says, Seamus is making an access ramp for a building. The ramp is in the shape of a right angled triangle. A diagram of the ramp is shown below. The lengths of two of the sides are shown. The angle A is marked. So here's our ramp here. Question 1. Write down the length of the side adjacent to the angle A. Okay, so here's the angle A. Well, the hypotenuse is the side that's always straight across from the right angle, the longest side, that's the hypotenuse. The opposite is the angle straight across from A, so this would be the opposite. And the adjacent is the side that's adjacent to angle A, the one that's touching the angle A, not the hypotenuse though. So the adjacent is the 260 centimeter side. Part 2 says, write down the value of tan A as a fraction. Well, you can use your tables book to help you here, or if you remember that the tan of an angle, tan of the angle A in this case, is the opposite over the adjacent. So the opposite in our case is 20, so the tan of A is 20 over the adjacent, which is 260. So that's the tan of A written as a fraction. Part 3 says, use your answer to part A2 to find the size of the angle A. Give your answer correct to the nearest degree. Okay, well, if we know that the tan of A is 20 over 260, well then A, the angle, will be the inverse tan of 20 over 260. And the way you get inverse tan is you press shift tan on the calculator, the shift button, and then tan. So shift tan 20 over 260, that gives us an answer of 4.3987, and on it goes. But we're going to give this correct to to the nearest degree. So that would be to the nearest degree, well, it's closer to 4 degrees than 5 degrees, so 4 degrees. Part 4, the angle A must be less than 5 degrees for the ramp to be acceptable. Is Seamus's ramp acceptable? Yes. Give a reason. Because it's less than 5 degrees. It's 4 degrees, so it's less than 5 degrees. Or you can say 4 degrees is less than 5 degrees. Okay, and finally part B. Killian is making a ramp for a different building. His ramp is also in the shape of a right angled triangle. A diagram of his ramp is shown below. It's the diagram. Uses the theorem of Pythagoras to find the value of x squared. Okay, well again, you can use your tables book here to help. The theorem of Pythagoras says that the theorem of Pythagoras says that if you've got a right angle triangle labelled ABC, with C as the hypotenuse, then A squared plus B squared is equal to C squared. Okay, so I'd label this A, this would be B, and the hypotenuse would be C. So if we apply Pythagoras to our diagram, we get 224 squared plus x squared is equal to 226 squared. Okay, so if we bring this 224 squared over to the other side, it becomes a negative 224 squared, and we get x squared is 226 squared minus 224 squared, which gives us 900. Well then, if x squared is 900, x is the square root of 900. If we do the square root of 900 on our calculator, we get 30. So x is 30. That's in centimeters. And that's the end of the question, number 11.